Hi guys, Cam back here at the Battler workshop. Well, we haven't done much in here for the last week. As a matter of fact, I haven't stepped foot in here for the last week. I apologise for not getting a video out earlier, but with Christmas coming up, work has been absolutely crazy trying to plan for some projects to be finished before the end of this year, and basically, mid-December it's just about all over Red Rover. So a lot of work to try and get those projects completed out. Having to do a fair bit of work out in the garden with springtime here. Everything's just gone absolutely crazy with growth, so out doing a lot of hedge trimming and cleaning up. So that's taken up a fair bit of time, and then 4 kids that takes up an awful lot of time. So they've obviously taken the priority over getting another video out, so I do apologise for that. Just some comments from the last video with the screen capture was the quality of the audio. So I've gone out and bought a little USB microphone, so we'll see if we can make that quality a little bit better and a bit more understandable as we go through these screenshots. As I promised last week, we're going to do a little bit of cores on these flywheels, these curved spoke flywheels. We're going to do how we'd set up a core to do some company emblems cast into the flywheel, or a pattern number or a drawing number. So I'll go through the screenshots that we've done for that. And because I don't have a foundry, we're going to do a visual cast on the screen. We'll see how that works out. We do that using a derived function to show us what the actual finished casting would look like. The other issue I've had too is the CAM software that I would normally use, a company that I did a lot of work for, a lot of modelling for programming for machining on the machining centres. I was going to pop down there and use their software, which is Visual Mill, great program. But trying to get the screen capture software onto their screens, and they're pretty finicky about what goes onto those programming computers, so I've sort of had to back away from that a little bit. So I've been doing a crash course any moment that I get on Fusion 360. So I've managed to get some code out. I've managed to get a post out on that, so we'll see how that looks anyway. If we've got time at the end of this video, we'll just quickly show you through what I've done on 360 about setting up the machining paths for that to get it post-processed and get a code out ready for the CNC router. All right, now that's out of the way. Let's swap over to the screen, and we'll take you through what we've done and how that core system works on patterns. All right, see you back in a tick. Righto guys, following on from last week, we'd created one half of the flywheel, and what I've gone and done offline is I've just quickly done the other half. So this one here has the extended boss on it, another 3mm, and this one's just plain. Other than that, and they're the same in every respect. I did mention too that often we'll want to allow, these smaller parts aren't so much of an issue, but we want to allow for a shrinkage rate in the castings for aluminium, and we can do that fairly simply by creating what we call a derived part and setting a scale factor to it. So that's done quite simply by creating another part, hitting the derive button and pulling in the flywheel. When we see that, we have the option over here of a scale factor. So let's just say we're going to do it in aluminium. So that's around about 1.8%ish roughly. So we also have the option of mirroring that part as well. We can hit OK, and that has grown up by an extra 1.8%. Let's do a measure on that. So that's gone up from about 146 up to about 148. So we've increased that diameter enough to cover the shrinkage. So we can do that quite comfortably with derived parts. We'll bomb out of that. The other thing too, and it's more so on smaller parts, is that sometimes when you're adding spray putty or building up with a high build type paint, you'll build these up quite thick, and you may not want to have them that thick, and I have had them in the past where that has happened, and put them out of proportion. We can use the thicken offset function, and I'll just go over the board with this and hit apply on that and that'll shrink that down. So you can, if you think you're going to build it up by 0.2 millimeters, you can allow that. Particularly with core boxes, core boxes will tend to, well, the cores will actually tend to shrink or be smaller if you do put up a high a spray putty on there, a high build spray putty on there. So you can build that into your model. So won't do it in this particular case. So they're the two flywheels or two halves that we've done for that curved spoke flywheel, and that's how they go together as an assembly. One on top of the other into the cope and drag, and these would be drilled and doweled together so that they become a matching pair, and that would be the cavity that we would end up with. So you get the two there with the one with the extender boss and one with the boss on the outside that's flush. Right. The other thing I did mention was that we were going to have a look at core prints. So I'll just turn those work planes off. So as I mentioned, sometimes you'll have customers that may have wanted to put a company logo into the surface of a casting, or it may be a pattern number, or it may be a drawing number, and we can do them fairly simply by doing what we with little core prints. So this is how the pattern would look like after you've machined it. You notice I haven't put any radiuses on there, but I'll go through that in a minute. So these are what's going to be formed into the sand when we mould it up. We're going to have these little cavities into the sand, and into those little cavities we're going to put our little cores, which will have our text that we want to put into the casting. So the core prints are made fairly simply. So all I've done there is just an extrusion of a sketch. And what I've done is, because we're going to put them into the flywheel, we're not going to have them standing out from the flywheel. We have to use negative text on that, and that's a fairly simple thing to do. We can actually go right way if we're going to have them raised, or we can go reverse to go the other way, as we've done here. So I've put the lettering in place, and then I've drawn the outline for what the core print is going to be, and then put that into place, and I've extruded it, and we can extrude with a taper. So I've extruded that with a 3-degree taper on that all over, so that'll withdraw out of the sand quite comfortably. Right, so and then we've just done a circular pattern on those just to create the other two with it. So we've created our core prints on our model, and then we want to create a core, or a core box actually, that we want to mimic that exact shape but in reverse. So all I've done there is I've just created a block which I've called the core, just off a standard sketch, and extruded it. And then I've assembled that onto the flywheel, as you can see there. To create the exact same core print in the core box. So we might just do that as a derived part. I'll just show you what happens there when we actually subtract that around anyway. So excuse me if we tend to go backwards and forwards a little bit on this. So we'll open up a part, we'll create a derived part, go back out of that curved flywheel, define it what I called it, flywheel test. Jeez, not that one. The one after it. Flywheel core. Nope. That's it there. Right, so we open that up, and we end up with an assembly box for derived parts. So I'll just rotate that around. And what we can then do is we can subtract one from the other. So the actual flywheel I want to subtract from the core box. So if I go OK on that, and we rotate that around, we'll see we've left an exact impression of what that core print is in that core box. So I'll turn that off, we don't want to save that. What I've also done is I've created a letter core which is going to sit in the bottom. I'll show you when we do the assembly on this. So I've created this letter core, and once again I've transferred from our sketch on the flywheel, I've transferred our, we're about to see, the sketcher which actually has the lettering in it. And I've put that over a block, and I've got that block reference from the center point there, so everything's in relationship to everything else. And we have what's called an emboss command, where I can emboss down onto or into that block as deep as I like. So I can go 1mm, 2mm, 3mm, whatever I like, or I can make that a raised. So if I do it this way, it comes up as a raised text. So that would create raised text on the actual flywheel, the way the core would be set up on that. And what I've done in the past with these, I've got a great sign maker that has a laser cutter that actually laser cuts this text out for me in the block in them. You know, it's a type of plastic that he uses. I've done these before, just go in there with a tapered D-bit to create the taper to machine them out. It happens fairly quickly, but yeah, taking it down to the sign manufacturer made life a little bit easier for me too. I just take the code down and they quickly do it for me while I waited. What I've also done with the core box that we took our derived part from is I've created a cavity that I'll machine in around the top there, because we need to be able to push that core out once it's finished. You can split the core boxes and split them in half and take them out that way, but I sometimes it's not even a slot, it's just a series of holes through here that you can just get a poker down to push the finished sand core out once it's been created. So what we're going to do now is we're going to show, if you like, a virtual core. So if we put all the core components together, the core box components together to create a sand core, and I set this up to be my sand, and I've put them inside. Everything's been mounted as it would be. So the other thing you've got that slot in there for too is obviously to ram the sand in through as well, but as I said, I do a series of holes and put the sand through that, but the slot's fairly convenient to get the sand into it to fill it and get it rammed into that text. So I'll take away the visibility on that. Where are we? It's not going with me. There it is there. So you can see that's our core, our sand in place, I guess, if you like. And once again, if we do a derived part, and we'll do that very quickly, so I'll set up a new part. And we do a derived part. I'll open that up. Right. So the thing that we want to leave intact is our sand that we've created, which is going to be, we'll make our negatives first, so we want that to be a negative. We want to leave the core in place. So if I go OK, it subtracts everything away. And if we have a look, it leaves the impression in the sand of the actual text that we've got. So that basically becomes our core that we're going to insert into those cavities that our prints create when we mould it up in the sand. So I'll save the changes to that. So that becomes our final core. Just get rid of those word puns. It becomes our final core. So that's how it would look in the sand as we're moulding up. yeah, let's just do a virtual. I've just created a coat that we would ram up with the sand, if you like. I've done an assembly, so we've put our flywheel, we've rammed it up in the sand, we've flipped it upside down, and we're going to withdraw the flywheel pattern out of the sand. And this is what we end up with. So that's the shape or the cavity that we're going to have left in the sand. So you can see the core prints we've got around outside there, plus the that shape of our flywheel that we want to do. And we'll do the second half as well and put the two together and cut our runners and risers into pour. But that's how our moulded sand would look. And then we would then insert those little cores. So these little cores, we'd make up 3 of those. And we would put them into the prints that have been left in the sand. So that's our box ready to cast. And then what I've done is I've made up some stock for the flywheel. So we would then overlay that into it. Once again, we'll do a derive function on that, and we would subtract everything away from the stock. And then we would end up with a final casting. That's what the lettering is going to look like. Obviously, we'll see that in 3 places. I haven't I updated that. No. I have to go back to that derive function and change that. I just did this with one core print when I was creating this this model, so that's why we only see one set of lettering in place. But as you can see, that's actually impregnated into the flywheel, and that's how the final casting would actually look with Emma's flywheel written in 3 points around that circumference. So that's just a little bit about, oh there it is there actually, sorry, I've got it there, I did a second one. So yeah, there we can see our lettering impregnated into that flywheel. We've left it off the side here a bit, so we've got a machining allowance, so everything should come up fairly even on that when we come to final size. So this is just one half obviously that we've done. I haven't done it as 2 halves as a cope and drag, but just to show what a virtual casting would look like. So hopefully that makes sense. I know it's fairly long-winded, and it's a bit of a snail trail process to go through with creating the parts, putting them together, deriving them, and coming back out again. But you can do that as many times as you like, and I have done cores inside cores to create parts that I need. So they can get fairly complicated and do your head in a little bit. I was going to show you what I've done with Fusion 360. So any time that I've got, I've been trying to learn this program. So that's the flywheel in place as it stands at the moment, ready to create our parts. So I've gone through and created our stock, which is here. I've set up our reference points that we're going to set as our machine reference points. This is where we zero our cutter off onto, which I always just default down to the top bottom right hand side. It's just the way that I tend to roll with it. Then I've gone through and created a facing pass. So basically all that's doing there is, in a couple of passes, I've used 19mm stock. We've got to face it down so that we come up to the top flat there. Then I've done a 2D pocket where I'm actually machining from that point down to the rim, because we've got a 3mm stick up on that just to remove as much of that material as we can. Then I've gone and done a 3D pocketing process where we're actually doing all the roughing out inside. With our cut, I'm just using a 1/4 inch flat end mill of the carbide bit that I use when I'm on the router. Once we've got that contour out, I've then done a contour around the outside, and I've opened that up a little bit. I've done 2 passes, one pass to the top, second pass to the top, next layer down, next layer out. And it just stops the tool binding up inside. It gives a place for the wood chips to go as we're cutting it out. And I've done that with tabs so that it doesn't cut all the way through. It leaves it intact. Then I've gone through and done a parallel pass, and I always do a secondary parallel pass at 90 degrees to it to give us our final contoured part. So if we go into our simulations, so I'll put stock in place there. We'll just simulate that up. I'll speed that up a little bit. So we're doing our initial facing operation, doing our popping operation, then we're going to go down and do our contouring operation. Take a lot of the meat out. We do the outside contour, where we leave our tabs in place, and we do our parallel finishing operations. So I'll go right through that and do that to the next operation. Obviously the graphics can't keep up, so it'll pass. There it goes there at the moment, it's very slow. So it does a pass one way, and at 90 degrees it does the pass the other, and that does our profiling. So that machines in all of our taper. I've got a fairly small step over on this, but I'm slowly building it. We'll get there until we end up with our final finished part, ready to go. So then we set up and do the second half. But as I said, I'm just going through learning how to use this product, because it's got some similarities to Visual Mill, but then it's got a lot of differences to Visual Mill. So just going through, there's a lot of writing in here. It's a little bit like a rabbit warren to go through to work out what each one is. I must admit, Visual Mill gives you a visual indication of off to the side of what each of these functions does. You can actually see in real time the changes that happen. So it's more me probably getting used to the program. It looks like a fantastic program to run with, but I've just got to have a little bit more time to try and learn it and get through its idiosyncrasies. And then I've got the post processing that I've done. So I've set that up for Mark 3. I'll give that a dry run on my CNC router that I haven't run for well over 3 years, so I've got to do a little bit of tuning up on that, just to make sure all the slop's out of it before we actually set up. So the next job we'll do, now that we've got our code done, I'll do a similar one for the second hand. We'll go into this with a little bit more detail before we actually go out to the machining. I'll show you how I've gone through it. It may not be right, as I said, I'm learning and made a lot of mistakes along the way, but maybe I can pass something on to somebody if they're doing this type of work. Yeah, we'll set up some stock in the 3D router and in the 3-axis router, and we'll try and machine those out and hopefully come up with a decent pattern and see how we go. I don't know when that'll be. As I said, work's very, very busy, and coming up to Christmas everything's getting very, very busy, so I'll try and get something out in the next week or two. We're actually on the machine. We'll see some machining. If it looks like this is going to fall over and it's not going to work out the way I want it to, I've got to spend some more time. I'll do some more on the slotting housing and get some videos out for that. Alright, I hope the audio quality's been a little bit better than what it was last time. I hope a lot more of it makes sense. Alright guys, we'll leave it for now, and we'll catch you on the next episode. Hopefully we'll be doing some machining of these flywheels on the router. Alright guys, see you then.